I am Dr. K.S.Rangasamy, Professor, Department of Mathematics, K.S.Rangasamy College of Technology, Tiruchenkoot, Tamil Nadu. In this video, we are going to discuss linear differential equations of second and higher order. First introduction, the differential equation of the form f of x comma y comma dy by dx d square y by dx square and so on d power ny divided by dx to the power n, that is equal to 0. Here y of x be the dependent variable and we are going to differentiate and the corresponding derivative dy by dx d square y by dx square and so on up to dny divided by dx power n. In the first degree and are not multiplied together is called a linear differential equation. Linear differential equation with the constant coefficient. So in the constant coefficient problem, so we are going to solve. So in generally solution be the complementary function plus particular integral. So first we are going to see the general linear differential equation of the nth order in the general form k naught d power ny divided by dx to the power n plus k1 d to the power n minus 1 y divided by dx to the power n minus 1 plus and so on up to kny, that is equal to f of x. So here f of x be the function of x. So where what are the k's? K naught, k1, k2, k3 and so on up to kn, all are constants. Then this equation, the first equation can be written as, that is d power ny divided by dx to the power n, that is equal to d to the power n. So this equation we can write k naught d power n plus k1 d to the power n minus 1 plus and so on plus k n minus 1 into d plus kn. So this common y we are taking outside, that is equal to capital F of x. So here this first function k naught d power n we can take f of d into y, that is equal to this right hand side capital F of x. So in general d power n is equal to d to the power n divided by dx to the power n, and similarly we can write. Then solving linear differential equations with the constant coefficient. In the complete solutions, that is f of d into y, that is equal to capital F of x is given by y is equal to the corresponding solution complementary function plus particular integral. This simply we call it as CF be the complementary function and Pi be the particular integral. So in the right hand side, in this first the f of d into y, that is equal to capital F of x, the right hand side f of x equal to 0 means this corresponding y, that corresponding solution y is equal to only complementary function. So this right hand side exists means we want to find the particular integral. Then what are the rules for finding complementary function? So in this first differential equation, so we are writing in this k naught d power n plus k1 d power n minus 1 plus and so on plus up to k nth term into y, that is equal to capital F of x. In the using left hand side we are finding the roots, that is the left hand side we are taking the first one, so put d is equal to m. So what is the auxiliary function? That is simply we call it as AE. The auxiliary function that is equal to, what is d is equal to m, we are substituting. So we are getting this equation 3, k naught m power n plus k1 m to the power n minus 1 plus and so on up to kth term, that is equal to 0. Then so what are the steps we are going to follow? So from this previous equation we find the root. So suppose d cube means d has 3 values, or m cube means m has 3 values, m square means m has 2 values. So this is corresponding roots. So if n roots are, suppose these roots are, let us assume m1, m2, m3. Suppose d to the power 3 or m power 3 means that is m has 3 values. So what is, let us assume m1, m2, m3. So m1, m2, m3 are real and different or distinct means. So what is the solution? The complementary function is equal to c1 e power m1x plus c2 e to the power m2x plus c3 e to the power m3x. So here there are 3 roots means, okay, these 3 roots are distinct. So what are the c1, c2, c3? All are constant. So if in the first case, the first one, the roots are n roots means m1, m2, m3 and so on up to mn. Okay, so this is next suppose that the roots are repeated means, for an example let us take m1 is equal to m2 and m3. So 2 comma 2 m3 is equal to 5 means, so 2 comma 2 2 is repeated root. Okay, so suppose using this what are the how to write the complementary function. Suppose C m1 is equal to m2 is equal to, that is equal to 2 means what is, that is c1 plus c2x e to the power this corresponding common value m1x plus the second term, that is c2 already c1 and c2 over, next c3 that is e to the power m2x, that's all. So here the second case, and the second case if two or more roots are equal, that is m1 is equal to m2 is equal to m3 and so on up to mk, where k is less than or equal to n. This complementary function we can write c1 plus c2x plus c3x square plus and so on ck x to the power k minus 1 e to the power m1x. Next remaining real root means as usual method in the first case we can apply, that is cn e to the power mnx. So this is second case. So now the first case roots are real and distinct, second case the roots are repeated. Third case, so suppose our roots are imaginary means, so what we are going to do, next is the question here. So in the come to the third point, the auxiliary has a pair of imaginary roots. So let us assume the roots are alpha plus or minus I beta. So alpha plus I beta, let us take m1 and m2 is equal to alpha minus I beta. These roots are imaginary. So imaginary means what we do, what is the corresponding complementary function, that is e to the power alpha is alpha be the, that is imaginary part, that is alpha plus or minus I beta, imaginary part, and real part alpha, imaginary part beta. Okay, so the complementary function e to the power alpha x into c1 cos beta x plus c2 sin beta x. Suppose the two real roots are this m1 and m2 are imaginary means, suppose the third root be the real means, that is what, c3 e to the power m3x. Suppose the fourth and fifth roots are equal means, similarly we have to follow the step 2. So what is, already c3 completed, c4 plus x into c5 e to the power m4x and so on. So this is third case. Okay, and similarly in the fourth case, if two pairs of imaginary roots are equal, so that is alpha plus or minus I beta. So let us assume m1, m2 is equal to alpha plus I beta, m3, m4 is equal to alpha minus I beta. So now m1 is equal to m2, that is equal to, let us assume m, and m3 is equal to m4, that is equal to alpha minus I beta. Okay, so in this case what is the, how to write the complementary function, e power alpha x into, just like in the second case, c1 plus c2x cos beta x plus c3 plus c4x sin beta x. That's all. So suppose if the next roots are different means, as usual now we can write what is c5, that is e to the power m2x or etc. or m5x. Okay, so these all are the very important cases in the how to find out the complementary function. The case 1, roots are real and distinct, and the case 2, the real roots are repeated, and the case 3, the roots are, if any two roots are imaginary, and fourth one, if two pairs of imaginary roots are equal means, that is third case. So we can solve a simple problem, solve the differential equation, d square y by dx square minus 8 into dy by dx plus 15y, that is equal to 0. So in this problem right hand side 0, so therefore our solution only the complementary function. So no need to find the particular integral, and we have no need to see the right hand side. So only the complementary function be the our solution. Okay, so here already we know d square by dx square is equal to d square. So for this first the equation can be written as d square y minus 8 dy plus 15y, that is equal to 0. So common term we can take outside, then d square minus 8d plus 15 into y, that is equal to 0. So next auxiliary equation, so d is equal to m. So this equation can be written as m square minus 8m plus 15, that is equal to 0. So using synthetic division or quadratic equation, we can easily find the root, that is minus b plus or minus square root of b square minus 4ac whole divided by 2a. Suppose if we follow this quadratic equation formula, so the roots are real or imaginary, we can easily find out. So this quadratic equation, so what is, this is simple equation, that is what are the roots are, m is equal to 3 comma 5. So here m is equal to 3 comma 5 be the roots are real and different. So how to write the complementary function? The complementary function c1 e to the power m1x plus c2 e to the power m2x already we know. So just m1 is equal to 3 and m2 is equal to 5. Therefore the complementary function c1 e to the power 3x plus c2 e power 5x. So in the f of x in the right hand side that is equal to 0. Therefore in this problem solution y is equal to only complementary function. Therefore y is equal to what? c1 e power 3x plus c2 e to the power 3x. Next, one of the another example. So this is d cube y divided by dx power 3 minus 6 into d square y by dx square plus 11 dy by dx minus 16y that is equal to 0. So in this problem d cube. So d cube minus 6d square plus 11d minus 6 into y that is equal to 0. The auxiliary equation d is equal to m. So m cube minus 6m square plus 11m minus 6 equal to 0. So in this equation, auxiliary equation, we are going to find the roots using synthetic division. So for our convenience we can take. So in this problem, so we are going to get m has 3 values, that is 3 roots we are going to get. So what are the roots are? So using any one of the method, we can easily find out the roots. So therefore the m value we are getting 1, 2, 3. So in this problem 1, 2, 3 be the roots are real and different. Therefore the complementary function c1 e power x plus c2 e to the power 2x plus c3 e power 3x. So what is m1 is equal to 1, m2 is equal to 2, m3 is equal to 3. So therefore complementary function c1 e power x plus c2 e to the power 2x plus c3 e to the power 3x. So in this problem also right hand side 0, therefore the solution be the complementary function. And next another small example, solve the differential equation d cube y by dx power 3 plus 2 into d square y by dx square plus dy by dx that is equal to 0. So similarly we can find the solution, the auxiliary equation is equal to what? M cube plus 2m square plus m equal to 0. So here roots are 0, minus 1 comma minus 1. So in this case 0 be the unique value, that is real value, that is we can take, and minus 1 comma minus 1 be the roots are repeated case, the second case. So therefore what are the complementary function? That is similarly c1 e to the power m1x. So c1 e power mx that is e to the power 0x that is equal to 1. So therefore c1 only plus c2 minus 1 comma minus 1 roots is repeated. So we can write c2 plus c3x e to the power minus 1x. So that is we can write e power minus x. So in this problem is also right hand side 0. Therefore the solution is y is equal to c1 plus c2 plus c3 x e to the power minus x. So these are this is how to find out the complementary function. Next fourth problem. This is slight different problem, that is d power 4 y divided by dx to the power 4 minus 2 into d square y by dx square plus y is equal to 0. So in this problem d power 4, d has 4 values. So our root is 4. So what are the 4? That is minus 1 comma minus 1, one of the root, and second root 1 comma 1. That is two groups of the real roots are repeated. So what is how to write out the complementary function? c1 plus c2x e to the power minus x. This my e to the power minus 1x. This is first minus 1 comma minus 1 corresponding complementary function. Next 1 comma 1. So what is plus c3 plus c4x e power plus 1x. So here minus 1 comma minus 1 is repeated and 1 comma 1 is repeated. So therefore c1 plus c2 x e power minus x for the first minus 1 comma minus 1 and 1 comma 1 corresponding c3 plus c4 x e to the power x. So this is the solution for this problem. Next, so we can go to how to find out the particular integral. So consider the equation d of y is equal to capital F of x. If right hand side, that is capital F of x, that is right hand side is not equal to 0. So not equal to 0 means right hand side exists, means we want to find the particular integral. So what is the first case? The particular integral. So particular integral pi is equal to 1 by f of d capital F of x, that is pi is equal to 0 if f of x is equal to 0. Case 1, when f of x equal to e power ax. So right hand side e to the power ax, that is equal to what? Let us assume that is capital F of x. So use the rule particular integral 1 divided by f of d be the from the left hand side e to the power ax. So e to the power ax in the first type. So we are going to substitute d is equal to a. D is equal to a. So what is we are getting 1 divided by f of a e power ax. If f of a is not equal to 0 means corresponding solution be the final solution. That is what? Corresponding particular integral. Suppose the denominator is equal to 0 in the second case. F of a is equal to 0 means we are multiply x in the numerator, then the denominator f of d differentiate with respect to d. So x into 1 divided by f dash of a e to the power ax. So in the second case, suppose f dash of a is not equal to 0 means this is the particular integral. Suppose f dash of a is equal to 0 means, so we can move to the third case. What is that? Is particular integral we are multiply x, already we have x, that is x square 1 divided by differentiate with respect to d in the f dash of d. So what is this corresponding? Already we have f dash of a. So what is we are getting? F double dash of a e power ax. So if f double dash of a is not equal to 0 means this is our final particular integral. Otherwise we can follow the same procedure. So and so on. So we can take a simple example, d square y by dx square minus 2 into dy by dx plus 10y, that is equal to e power 2x. So in this problem we want to find the complementary function and the particular integral. So our general solution, complete solution is equal to complementary function plus particular integral. So first one, the auxiliary equation m square minus 2m plus 10 equal to 0. So m is equal to imaginary, that is 1 plus or minus 3i we are getting. So therefore the complementary function e power alpha, that is real value 1. So e power 1x into c1 cos beta x, beta be the corresponding imaginary, that is 3x plus c2 sin 3x. So this is complementary function. Next, how to find out the particular integral, that is 1 divided by f of d into capital F of x, that is equal to what? 1 by f of d e power 2x from the given problem right hand side. So now we are going to substitute d is equal to 2. So what is in this left hand side, that is d square minus 2d plus 10. So we can substitute it, that is what is d is equal to 2. So we are getting 1 by 10 e power 2x. So this is the particular integral. Suppose in the same problem denominator instead of 10, suppose we are getting 1 by 0 means we are going to multiply the next step, we are going to multiply x in the numerator, then there is a d square minus 2d plus 10, we are differentiate with respect to d one time. So once again we have to substitute d is equal to 2, then we are getting answer. Suppose if denominator 0 means we proceed once again the same procedure we have to follow. So what is the complete solution? Y is equal to complementary function plus particular integral. Therefore y is equal to e power x into c1 cos 3x plus c2 sin 3x plus 1 by 10 e to the power 2x. So this is the solution of the given problem. And a simple example, e power x. So the left hand side, as it is, we can use that is auxiliary equation, and we find the roots and the complementary function. Then particular integral, very simple, that is e power x, e power 1x. So we are substituting d is equal to 1. D is equal to 1. Okay, in this case, the denominator we are substituting d is equal to 1 means in the what is in this equation 1 square, that is 1 plus 1 minus 2, denominator 0. So denominator 0 means, so we are multiply x in the numerator and the denominator d square plus 2 d minus 2 we differentiate with respect to d. So therefore 2d plus 1. So once again we have to substitute, that is d is equal to 1. In the second case, so we are getting the final value denominator 3. So what is this corresponding solution particular integral? X e power x divided by 3. So therefore we can write the complete solution. So the complete solution is y is equal to complementary function plus particular integral. So therefore y is equal to c1 e power minus 2x plus c2 e power x plus x into e power x divided by 3. So similarly we can easily calculate the complementary function and the particular integral. So that is on the right hand side, not equal to 0 means we want to find the particular integral. So in the first case we are taking only e power alpha x only. Thank you.